Good evening, my dear friends. So, welcome you all for today's GTQ of Strength of Materials for GATE 2022. So, I selected the questions in such a way that it is going to cover all the concepts. Those who are thorough with already, the exam is almost 2 weeks time is there. Those who are preparing for GATE 2022. So, your preparation might have already completed. So, those who are thorough with the concept, they are able to do all the questions. Since the GATE is a completely test for the concepts. So, the student who is thorough with the concepts, and especially the students who have attended my lectures, they are able to do each and every question. So, I have taken some are the MSQ questions, some are the MCQ questions, as well as NET questions. So, I have framed around 22 questions. We will check it. Within 3 hours I am planning, 6 to 9, we'll try to cover all the important concepts. So we'll come to the first question. And the questions are selected in such a way that which are not covered. Recently I prepared the RTQ, revision through questions, and last year CTQ. And most of the questions which are not discussed in the class. Some questions, maybe one or two questions may be repeated, is going to be there. So I'm coming to the first question. First question I had taken from the Mohr circle. The question states that which of the following Mohr circle is or are is a MSQ question. Is or are correct for a thin spherical pressure vessel subjected to both internal pressure as well as the torque. So 4 more circles are given. So first try to give the answer, try to write down the question and try to answer it. So we'll check it how many are going to give the correct answer for this question now. 4 more circles are given for a thin spherical pressure vessel subjected to both internal pressure as well as the torque. 4 more circles are given. You have to identify which are the more circles are correct now. Can you give the answer now quick? Then I'll come to the explanation. So most of the friends, they have selected answer is going to be D. Mr. Naresh Kumar, Shreya Gupta. Everybody is going for option B. Option B, option D, option D. So it seems to be you are not going through the question. In GATE questions, they are framed the options in such a way that they all seems to be correct. But you select the appropriate one. Is a MSQ question. Maybe once may be correct or more than one may be correct. Don't fix the answers. Everybody is going for option D. Option D is valid when now? When thin cylindrical pressure vessel under internal pressure. But here torque is also there. Here torque is also there. If there is no torque, option D is going to be. So option D is not correct now. Option D is correct only under what now? Option D is going to be correct when a thin cylindrical pressure vessel under internal pressure. But here torque is also there. Here torque is also there. So option D is not correct now. Anybody quick? Somebody is given A, D, A. So far I not received the correct answer. So my dear friends, please go through the question thoroughly. Try to understand the question. Don't fix the answers. Before selecting the correct option, go through the question thoroughly, what is given and which one are the options are there, which one is correct. Options are what now? A, B and C. All the three options are correct now. All the three options are correct. B is also correct. A is also correct. C is also correct. So answer will be A, B, C. First you have to draw the state of stress. This is a state of stress only when pressure is there. For this case, answer will be D. So without going to the question, everybody is selecting the D. But here torque is also there. Due to torque, you are going to get a torsional shear stress. This will be the state of stress due to pressure as well as what the torque. So now sigma x and sigma y are equal to hoop stress, and tau xy is equal to tau t. What the hoop stress equation? No, PD by 4T. And torsional shear stress is T by ZP. Thin pressure vessel, the ZP is what now? Pi d square by 2 into T. Now, what the principal stresses now for this case now? If the magnitudes are given, only one circle will be correct. Here magnitudes are not given. We don't know pressure, we don't know diameter, we don't know thickness, we don't know torque. So we don't know the magnitudes. But sigma x and sigma y are equal. Tau xy equal to 2t by pi d square t. So for this case, the principal stresses will be this is the equation. What the principal stress equation already known to you. What the sigma 1, sigma 2, 1 by 2 sigma x plus sigma y plus or minus square root of sigma x minus sigma y whole square plus 4 tau xy square. So it will be what now? Since sigma x and sigma y are equal, so it will be what now? 1 by 2 sigma x plus or minus tau xy. Now if tau xy and sigma x are equal, then sigma 2 will be 0. Then at that time the first circle will be there. If sigma 1 will be here it will be 2 will not be here, 1 by 2 will not be here, 1 by 2 will not be here. So it will be now it will become as a uniaxial state of stress. For uniaxial state of stress, more circle is a circle tangential to y-axis. Then this will be the correct now. So this will be the answer when sigma x, sigma y and tau xy are equal in magnitude. Next, if tau xy is greater than sigma x, if tau xy is greater than tau xy is greater than sigma x, then sigma 2 will be negative. Sigma 1 will be positive. Sigma 2 will be negative. So then second case is correct now. B is correct. So when the B is correct now, when tau xy is greater than sigma x or sigma y, because sigma x and sigma y are same. Similarly, if sigma x is greater than tau xy, sigma 1 is positive, both are positive, then third case is correct. So option B, C is correct when sigma x is greater than tau xy. So that's the reason answer will be what now? A, B and C. When option D is correct now, option D is correct when only internal pressure is there. So this is the explanation for the question now. So A, B and C. I hope it is clear now. Once I am mentioning now, option D is correct only when internal pressure is there. But when torque is also there, then at that time, option A may be correct, or B may be correct, or C may be correct. It is depend upon the magnitudes. If sigma x, sigma y, tau xy are same, so it will be a uniaxial state of stress, then option A. If tau xy is greater than sigma x, then sigma 1 and sigma 2 are what? One is a positive, one is a negative. Then more circle will intersect the y-axis. Then option B. Option C is correct when sigma 1, sigma 2 both are positive. That is, when sigma x is greater than tau xy, then at that time, option C is correct now. So I'm not writing the what I'm. You can follow the lecture, those who are already thorough with the concept. Now, I'm coming to the next question. I will take some more MSQ questions, theory questions. So can you give the answer for this question now? Which of the following statement is or true? Or true? 4 statements are given. So this was the MSQ is introduced in GATE 2021. But last year, there was no question on MSQ. But this year, you may likely to expect it. MSQ question can be answered by the student who is thorough with completely their concepts and the basics now. So anybody answer for this question now? Question number 22. So Mr. Ankit, somebody is given ABD, ACD. First statement is correct or incorrect now? So some friends are given ABD. Some friends are given BCD. So which is the answer for this given question now? Which one are the correct statements now? First statement is the correct or incorrect now? First statement is the incorrect now. First statement is the incorrect. Everybody is selecting the first statement now. First statement is incorrect. Second statement, for the longitudinal strain. Longitudinal strain is a normal strain in the direction of the load. This statement is valid only under uniaxial state of stress. Everybody is going for the longitudinal strain, the change in length upon virginal length. This statement is valid only under pure axial load. Longitudinal strain is a normal strain in the direction of the load. That is, this statement is valid only under uniaxial state of stress or otherwise pure axial loading. So what the generalized definition now? If it is when this statement is correct, if clearly mentioned under uniaxial state of stress, longitudinal strain, then at that time is valid. Otherwise pure axial loading case is valid. This is valid under pure axial load. This statement is correct only under pure axial load. PAL means pure axial loading. But in the question is not mentioned pure axial loading now. So first statement is not correct now. When thermal deformation of a bar made of same material is restricted either completely or partially, thermal stress and thermal strains are unlike in nature. This statement is correct or incorrect now? The second statement is correct. When temperature increases, thermal strain is a tensile, but thermal stress is going to be compressive. So always thermal stress and thermal strains are unlike in nature. Second statement is correct. Thermal stress and longitudinal strain are like in nature. Thermal stress and longitudinal strains are like in nature. But thermal stress and thermal strains are unlike in nature. When temperature increases, length will increase. Thermal strain is going to be a tensile. But reactions are acting as a compressive load. So thermal strain is a tensile and thermal stress is a compressive. They are unlike in nature. Next. Material with more Poisson's ratio, positive Poisson's ratio, exhibit more shear deformation than material with negative Poisson's ratio. This statement is also correct. Generally, you are going to study most of the material Poisson's ratio is positive. When Poisson's ratio is positive, longitudinal strain, lateral strains are unlike in nature. But when Poisson's ratio is negative, longitudinal strain and lateral strains are like in nature. Means longitudinal strain is also tensile, lateral strain also tensile. If a bar is made with a what? A bar is going to be pulled and the Poisson's ratio is going to be negative. Then at that time what happens now? Length is also increase and depth is also increases, width is also increases. Then longitudinal strain, lateral strains are going to be like in nature. Means they will exhibit more change in volume, but less shear deformation. And what about the last one now? Under plane strain condition, non-zero strain and stress components, non-zero and strain and stress components are epsilon x, epsilon y, gamma xy, gamma yx, sigma x. There's a small printing mistake here. This is a printing mistake. It is not sigma x, sigma y. Under plane strain condition, strain tensor is the 2 by 2 matrix. Under plane strain condition, strain tensor is the 2 by 2 matrix. Therefore, non-zero are going to be 4. Epsilon x, epsilon y, gamma xy and gamma yx. But under plane strain condition, we are not going to get a plane stress condition. Then stress tensor is a 3 by 3 matrix. So non-zero strain components are 4. But non-zero stress components are 5. Epsilon z is 0. Epsilon z is 0. But sigma z is non-zero. Strain tensor is 2 by 2. But stress tensor is epsilon z is 0. But sigma z is non-zero. So answer for this given question will be B, C and D. B, C, D. Is a strain tensor for plane strain. Stress tensor will be sigma x, sigma y, sigma z. So those who have gone through the QRC of my strength of material quick revision concepts, then directly can answer this now. when mu is negative, the materials called as axiatic materials. Axiatic materials are anti-rubber or dilational materials. So they will exhibit more change in volume. But less shear deformation. Because of longitudinal strain and lateral strains are going to be like in nature. So more change in volume. But when mu is going to be positive, when mu is positive, longitudinal strain and lateral strains are unlike in nature. So change in volume is going to be less, but shear deformation is more. Shear deformation is more. Check it now. G is equal to E by 2 into 1 plus mu. From this one you can check it now. When mu is going to be positive, when mu is going to be positive, G will be less. When mu is going to be positive, G is going to be what? Less. When G is less means what now? Shear deformation is more. When mu is going to be negative, when mu is going to be negative, G will be more. When G is more means shear deformation is less. That's why the third statement is given as what? A material with Poisson's, positive Poisson's ratio exhibit more shear deformation than material with negative Poisson's ratio. The answer for this question will be BCD. First statement is incorrect. Second, these three statements are correct. BCD the answer. So we'll come to the next question. We'll take the next one more MSQ question. Which of the following statements are correct with respect to beams having constant flexural rigidity, constant EI? So 4 statements are given. Quick. Go through and give the answer now. 4 statements are given. Which of the following statements are correct with respect to beams having constant flexural rigidity? EI is same. It is also MSQ question. First statement is given as. So can you give the answer now? We'll check it now. Ankit, ABC, B and D. Anybody quick? 2 friends are given. ABC, ACD, BD, B. Love Kumar. ABCD, all are correct. B and D. B and D. So go through the what now? MSQ should be what now? You should be thorough with the concept. Only first statement is correct here now. In this case, only the first statement is correct. MSQ means maybe one may be correct or more than one may be correct. Here only first statement is correct. Only first statement is correct. Second statement is incorrect. Third statement is incorrect. Fourth statement is incorrect. At point of counterfacture, bendment is not zero. Bendment is going to be what? Changes its sign. At point of counterfacture, bendment is going to be changes its sign. But bendment may or may not be zero. At point of counterfacture, bendment changes its sign. But bendment may or may not be zero. So second statement is what now? Incorrect now. At point of counterfacture, bendment may be zero. Everybody is going for directly bendment zero. Point of counterfacture what now? Where bendment is going to be changes its sign. Left side is a sagging mean, right side a hogging will be there. Suppose the BMD is like this. This is also point of counterfacture. Here also point of counterfacture. But here bendment is not zero. Here bendment is zero. But in both the case, what? A bendment is going to be changes its sign. A, B, C, and D. At A and D, bendment is zero, but that's not a point of counterfacture. A and D, bendment is zero. It is not a point of counterfacture. Their bendment is not changing sign. What about B and C? Their bendment is changes sign. Bendment is changes sign. But at B, bendment is not zero. Suppose this value is what now? M. At B, bendment is what now? M. At C, bendment is zero. But both are point of counterfacture. So what the point of counterfacture definition now? Point of counterfacture is the cross section where bendment is going to be changes its sign. But bendment may or may not be zero. But most of the low standard textbook directly they are going to mention the point of counterfacture is what now? Where bendment is zero. B and C are point of counterfactures. POCF, point of counterfacture. Next, when shear force 0, shape of elastic curve is not a circular arc. Maybe a circular arc, maybe straight line. When you are going to get a circular arc, when shear force 0 and bendment is constant, when F is 0, elastic curve is a straight line. When shear force is 0, bendment is a non-zero constant, then it is a circular arc. So shape of the elastic curve not only depend upon the shear force, but it also depend upon the bendment. When shear force 0, bendment is also 0. Then you are going to get a straight line. When shear force 0, bendment is a non-zero constant is a circular arc. Otherwise, if it is mentioned what? A pure bending. And a pure bending, it is going to be a what now? Circular arc will be there now. So third statement is incorrect now. Next, bendment is maximum at a cross section where shear force changes sign. This statement may not be correct now. Always is not correct now. This statement is valid when there is no bending couples. This statement is correct only when there is no bending couples. When there is no bending couples. If it is going for what? A bending is maximum at a cross section where shear force changes its sign. This statement is correct when there is no bending couples. So BCD is not correct, but A is correct now. In the absence of axial load, neutral axis coincide with one of the centroidal axis in the plane of cross section about which bending couple or bending is acting. But most of the friends, they have selected first statement is incorrect now, but they have selected BCD. So answer for this question will be only A. Suppose the couples are like this. These are the bending couples. They are in which plane now? Vertical plane. Vertical plane. Then neutral axis coincide with horizontal centroidal axis. These couples are acting in what? A vertical plane. Vertical plane. So for this plane, suppose x-axis is perpendicular. Then neutral axis coincide with x-axis. That is the horizontal centroidal axis. If the bending couples are acting in horizontal plane, then neutral axis coincide with vertical centroidal axis. That's why it is clear now. So at neutral axis need not coincide with the HCA under vertical bending. Under vertical bending, neutral axis coincide with horizontal centroidal axis. Horizontal bending, neutral axis coincide with vertical centroidal axis. But this statement is also correct when there is no axial load. That's why clearly mentioned what now? In the absence of axial loads. In the absence of axial load, neutral axis coincide with one of the centroidal axis in the plane of cross section about which bending couple or bending is acting. Now I'm coming to the next question now. So can you go through this question quick? Which of the following are true? Which of the following are true? Quick. Whenever MSQ is there, go through all the it is not a MCQ. MCQ only one statement is correct. But MSQ, maybe one or more than one may be correct. It should be thorough with the basics and basic definitions now. Anybody want the answer now? Quick. Mr. Raghu, previous question is given correct, good. Only Mr. Raghu is given the correct answer now. For the previous question, only option A. Remaining already what now? Remaining friends also they are thorough, but they are not going to the question thoroughly. If your answers are incorrect, try to identify where you are committing the mistake. You know everything, but you are in a hurry what now? You are making a mistake. So anybody what the answer for this question now? Which of the following are true? T cross-section beams under transfer shear loads subjected to shear force, bending and twisting. In presence of eccentric axial loading, neutral axis lies outside the plane of cross-section when axial stress greater than maximum bending stress. Under combined stresses, principal plane never coincide with X and Y faces, but maximum shear stress plane may or may not coincide with Y faces, X and Y faces. On two complementary planes, shear stress are equal and unlike in nature and vice versa. Anybody quick? Once again, BCD, C, BCD are true, C and D are true. A and D, BCD, my dear friends, for this question, the correct answer will be A is correct, B is correct, C is correct, D is not correct. It is given vice versa. Vice versa. On complementary planes, shear stress are equal and unlike in nature. But whenever shear stress are equal, unlike in nature, they are not complementary planes. Vice versa is not valid. On two complementary planes, shear stress are equal, unlike in nature. But when shear stress are equal and unlike in nature, they are not complementary planes. Simple example is what now? Planes of zero normal stress. Planes of zero normal stress. On that plane, shear stress are equal and unlike in nature, but they are not complementary planes. So vice versa is not valid. It's incorrect now. Always on two perpendicular planes, shear stress are equal and unlike in nature. But when shear stress are equal, unlike in nature, they need not be a complementary planes. On planes of zero normal stress, shear stress are equal and unlike in nature, but they are not complementary planes. So what is correct statement now? On two complementary planes, shear stress are equal and unlike in nature. But when shear stress are equal, unlike in nature, they need not be a complementary planes. Vice versa is not valid. T cross-section beams under transverse shear load subjected to shear force, bending and twisting. This statement is correct. Why now? Here you need the shear center concept. In T cross-sections, shear center and centroid will not coincide. So whenever the line of action of the load, whenever the transverse shear load, line of action of transverse shear load passes through the shear center, then there will not be any twisting moment. But here in T sections, shear center and centroid will not coincide. This is valid because of shear center when shear center coincide with the centroid, then under transverse shear load there is no twisting moment. In which cross section shear center and centroid will coincide? The cross section which are symmetric about both horizontal centroidal axis and vertical centroidal axis. That is circular section, rectangular section, square section, symmetric I section. In all this case, they are symmetric about both horizontal centroidal axis and vertical centroidal axis. In that case, shear center will coincide with the centroid. Suppose by chance, in place of T section, if it is given I section, in place of T section, if it is given I section, then this statement is incorrect now. In place of T section, if it is given I section is symmetric about HCA and VCA. HCA means horizontal central axis, VCA means vertical central axis. In that case, shear center will coincide with the centroid. then there is no twisting moment. But T section, channel section, inverted T sections, inverted what now? C section, T sections, L sections. In all this case, what now? Shear center and centroid will not coincide. Shear center and centroid will not coincide. Then under transfer shear load, the cross section is also subjected to twisting. It's subjected to twisting, bending also. So this statement is correct. In presence of eccentric, those who have gone through the QRC, directly can answer it. Just now you have seen, whenever axial load and bendment both are acting, eccentric axial load equal to one axial load as well as one bendiment. Whenever axial load and bendiment are acting simultaneously, neutral axis never coincide with the centroidal axis. Neutral axis may coincide with the extreme fiber, may coincide with the inner fibers, may lies outside the plane of cross section. Under combined stresses, combined stress means both normal and shear stress are acting. So principal planes are never coincide now. But tau max plane may coincide with x and y faces. So if you are thorough with, I am not going for the explanation of all this thing, because I want to explain, you should be thorough all this thing now, basics. Since you are already thorough with all the concept, directly I am giving the answers now. So answer for this given question will be A, B and C. When axial stress and bending stress are equal, neutral axis coincides with one of the extreme fiber. When axial stress less than bending stress, neutral axis coincides with inner fiber. When axial stress neutral axis lies outside the So I selected 4 MSQ questions. Very few friends, 1 or 2, they have given the correct answers. So these questions can be answered correctly by a student who is thorough with this basic definitions and the concept. So these are the 4 MSQ questions. Now I am coming to the next question now. So can you give the answer for this now? Self-weight question. Elongation of a vertical prismatic bar due to its self-weight is given by gamma is the weight density, that is the Newton per meter cube, and stress strain diagram for this bar is defined by sigma is equal to Means stress strain curve is not a straight line, it is a parabola. So here directly Hooke's law is not valid now. Default we are assuming as what now? Stress strain curve is what now? Linear elastic material. We are considering the linear elastic materials. If nothing is mentioned, we are assuming the linear elastic. By chance, this condition is not given. If this condition is not given, then what the elongation of a prismatic bar under its self-weight? Gamma L square by 6E. Or gamma L square by 2E, gamma L square by 2E under self-weight. Anybody can give the answer now? Default you are considering as a linear elastic. Entire strength of material subject you are assuming the material as a linear elastic. For this case, change in length is given by WL by 2AE. W is what now? Self-weight. Self-weight is gamma AL. So it will be gamma L square by 2E. So this equation is valid under linear elastic. But if a conical bar is given, the constant is going to be 6. Initially I have given gamma L square by 6E. That is valid in case of conical bar. In the question is given as what now? Vertical. This is valid when it is a linear elastic. But in the question is given as what? It is not a linear elastic. Sigma is equal to C epsilon whole to the power of that what? The parabolic. No? The stress strain relation is like this. So can anybody give the answer for this question now? Default you are assuming the linear elastic, but in the question is given as what now? Stress strain diagram for the bar is defined by sigma equal to a constant C epsilon whole to the power of 1 by 2. So I will you can complete it. I will also try with the same question. How to get the change in length? Change in length, you are going to take a small strip, find out the change in length of the small strip, then you have to do the integration. consider an arbitrary cross section. Take a small strip. The length of the strip is dx. So first find out the change in length of the small strip. What the self weight of this pink color portion, gamma AX? Gamma is the weight density. Now, what the stress at XX now? What the stress at XX? So we'll check it if any of the friends has given the correct answer. So they have given the answer is B. Good. These friends are given correct answer now. Shailendra Singh, Anshuman Pandey. They have given the correct answer. Answer is B. Answer is B. For this given question, from some friends have given the correct answer already. B the correct answer. Now what the stress at XX? Then what is the strain? Change in length of the small strip. Now this you can substitute in the given relation. The relation is given as sigma xx. Now you can substitute these two in this relation, then find out the change in length of the small strip, then you can do the integration. What the limits now? X is taken from the bottom, so the limits are 0 to L. X is measured from the bottom. At the bottom, X is what? A 0. At the top, X is going to be L. So now here, change in length of the small strip. Now you can do the integration. Zero to L. You will get it. Answer will be gamma square L cube by 3 this gamma square L cube upon 3c square. So option B is correct. Option B is correct. So most of the students have given the correct answer. But MSQ questions, very few friends are given the correct now. But for this question, everybody is given the correct answer. So I'll come to the next question now. I'll take the questions in such a way that which are going to next. Okay. So can you give the answer for this now? What is given in the question now? Two wooden members of 15 to 200 mm uniform rectangular cross section are joined by the glued joint. D is missing. Glued joint. This is what now glue. Glued joint. Two wooden members, rectangular cross section. This dimension is missing here. This dimension is 200. 200. Width is missing. And this is what now? This joint is at an angle of 60 degrees. Now what is asking the question now? Determine factor of safety if failure stresses for the glue in tension and shear are 1.25 megapascals and 1.5 megapascals. That is FUT. And it is subjected to pure axial loading. Pure axial loading. Now which one is the weaker one now? When I am going to pull it, the failure will occur along this joint. This joint is at an angle of what? 60 degrees. Weaker one will be the what now? This glued joint. So whenever the load is greater than the what now? Strength of this glued joint, then failure will occur now. So on this joint now, how many stress are going to be there now? Both normal and shear stress are there. This plane is the oblique plane. Is it a normal load? Normal load for the cross section. For this plane is the oblique plane. For the oblique plane, this load will become as a what now? Normal load as well as shear load. Then you are going to get both normal and shear stresses. Therefore, you have to consider both failure due to normal stress, that is the tensile stress, and failure due to shear stress. Both should be considered. Can you give the answer for this now? Anybody quick? This load is given as, axial load is given as 5 kilonewtons. Cross section is rectangular cross section. Width is 200. Now the plane is given at an angle of, the glued joint is at an angle of 60 degrees is given. So now what is the theta value now? So generally theta will be measured from the cross section, but here the 60 degrees is given with the horizontal, that is what now, longitude axis given now. So theta will be what, a 30 degrees. So under pure axial loading, you are going to get a uniaxial state of stress. So this will be the theta. Then you can use your strength criterion. Normal stress should be less than or equal to permissible normal stress, and shear stress should be less than or equal to permissible shear stress. Then you are going to get the 2 factor of safety. Then you have to take the correct factor of safety now. Safe condition with respect to tensile failure. Sigma n at an angle of theta should be less than or equal to permissible tensile stress, SUT by n. What the sigma n? What the SUT is given in the question now? 1.25 factor of safety. So now you can substitute the sigma value. Sigma is I am calling this factor of safety is N1. Check it, this will be so this is the maximum or what now? It's the minimum value or what now? Minimum value for the factor of safety or maximum value now? Is the maximum should be less than or equal to. Like similarly, you have to consider with respect to shear failure. But the shear stress equation now, sigma by 2 sine 2 theta on an oblique plane. sigma by 2 sine 2 theta. So this factor of safety N2 I am taking. Now this is given as 1.5 sigma by 2. Sine 6t. N2 will be, check it, the N2 value is going to be 6.928. So what should be the final factor of safety? What should be the final factor of safety? So with respect to tensile failure, I am getting factor of safety is what? 1.33. It is about now minimum or maximum now? Maximum. Should not be more than this now. Less than or equal to. Here is also maximum. For shear failure, the maximum factor of safety is 6.928. For tensile failure, the maximum factor of safety is 3.33. So finally, what should be the factor of safety? So N should be less than or equal to smaller of that is 3.33. 3.33. Now can you give the what is the answer now? What is the answer for this question now? For tensile failure, the maximum factor of safety 3.33. For shear failure, the maximum factor of safety 6.928. Everybody is going for the maximum. You should go for the minimum now. This is the maximum. You should not go above this now. You should not go above this now. Less than or equal to this means a maximum factor of safety for with respect to tensile failure. Is the maximum factor of safety with respect to shear failure. Everybody is taking 6.928. If you take the 6.928, it is the unsafe with respect to tensile failure. So you have to take a smaller value. Smaller value, 3.33. Now can you check the options now? Can you check the options now? (3.33), 6.928. Finally, what should be the answer now? What the answers are given now? 3, 6.928, 3.4 and 7. 7. Options are given like this. 3, what should be the answer now? A. A will be the answer. Some students are going for 6.928. That is the incorrect now. Some students are going for 3.4. Is the maximum less than or equal to. Final factor of safety is what now? Less than or equal to 3.33. Less than or equal to 3.33. Means you should not go above this value. Should not go above this value. Then you have to select a value below this now. So what the, which value is less than 3.333? So answer will be A. Because most of the students, they will not put this less than or equal to. If you don't put this less than or equal to, you are going to get an incorrect answer now. Because most of the textbook, they are using the is equal to symbol. If you are going to put is equal to symbol, then you cannot decide if the minimum or maximum value cannot be decided. Most of them are going to put it like this. Most of them are going to put it here, is equal to symbol, they are going to take it now. then they are going to get 3.33 and 6.928. Then they are going to take a larger value. So always use this less than or equal to. Then you can decide what is the minimum value or maximum value. Is a maximum value for tensile failure, is the maximum value for shear failure. So finally it should be safe with respect to both the failure means you have to take the smaller of the above value, that is 3.33. If the option is given 3.33, if NEAT question is given, numerical answer type, by chance this question is given as NEAT, then you have to go for 3.33. But the MCQ question is the MCQ question, then you have to go for a value below this 3.33. Which one is the below this 3.33? A. 3. Answer will be A. So some friends are given correct answer, some friends are given the incorrect now. Naveen Kumar, Rohit Kumar, they have given the correct answers now. Okay, good. So we'll come to the next question now. Question number 11, I'm going to take it. 1 minute. Let me check that question number. Number 11. So this is one more question. What is given in the question now? A rectangle has been scribed on the side of a large steel pressure vessel. After pressurization, the biaxial stress condition of the rectangle is as shown in the figure. Percentage change in the slope of the diagonal AC is E is equal to 200 gigapascal, G is 80 gigapascals. A cylindrical pressure vessel is there. Initially on the cylindrical pressure vessel, a rectangle is drawn, scribed. Then fluid is pumped inside. Due to fluid pressure, you are going to get a hoop stress and longitudinal stress. Radial stress is going to be neglected, default radial stress is neglected. Then you are going to get a biaxial state of stress condition. Already given the biaxial state of stress. This is a rectangle. So here, so these are missing. A, B, C, D. Now it's asking previous question is a uniaxial state of stress. Now this is a biaxial state of stress. Now it's asking what is the percentage change in the slope of the diagonal AC. Slope is nothing but what? A tan theta. So this is what the tan of this one is going to give the slope of this diagonal. But this is what before pressure is acting. But after pressure is acting, what happens? These are the stress are developed. Then length increases, diameter will increases, then this diagonal will change. Then now this theta is also going to be changes. So what the change in percentage change in slope of this diagonal AC? Tan theta dash minus tan theta upon theta. So it is what now? Sigma x is given, sigma y is given. Anybody give the answer for this question quick? This is what this rectangle is representing now. A rectangle is scribed on the side of a large cylindrical pressure vessel. Steel pressure vessel. Default, you have to go for a cylindrical pressure vessel. After pressurization, directly is given. Actually, how to get this now? This is nothing but a longitudinal stress. Longitudinal stress given by PD by 40. The hoop stress. Hoop stress is what? A PD by 2T. So hoop stress is double the longitudinal stress. That's why it's given as what? 100. So actually, if the pressure is given, diameter of the shell is given, thickness is given, this value is going to be calculated by PD by 4T. This is PD by 2T. Hoop stress is double the longitudinal stress. This is A, T, D. This dimension is given as 100. If I am calling this B. So this is the initial, before fluid pressure is there. That is before load is acting. So what the slope here now? Tan theta. Slope is nothing but the tan theta, which is what now? D by B. Tan theta. 1 minute. This is given as 80, sorry. This dimension is given as 80. This is given as 80. So due to fluid pressure, what happens? Now length will increase, diameter will increase. Then automatically this size of this rectangle will change. So now I'm assuming this is when pressure is 0. When pressure is 0. This will be B dash. This is B plus delta B, which is equal to 1 plus epsilon x. What the epsilon x, what the strain in the x direction? Change in width upon virginal width. So this would be equal to 1 plus epsilon x. Epsilon x is equal to delta B by B. Similarly, what about this dimension? D dash. D plus delta D. That is 1 plus so what is the slope here now? So now you have to find out the epsilon y and epsilon x. It is the biaxial state of stress. What the epsilon x and epsilon y? What the epsilon x 1 by E sigma x minus mu sigma y. Epsilon x is what now? 1 by E sigma epsilon x is 1 by E sigma x minus mu sigma y. Find out epsilon x and epsilon y. You know the equations, substitute it, then you can find out the percentage change in the slope. Anybody give the answer now? What is given in the question? Sigma x is given as 50. Sigma y is 100. E is 200 gigapascals. G is 80 gigapascals. From this one, mu will be G. So from this one, mu is equal to then you can use the epsilon x equation 1 by E sigma x minus mu sigma y. So you can calculate it now. So you are getting epsilon x as similarly epsilon y epsilon y value is I'm not doing the direct line, I'm writing the values now. Now you can find out the slope. Tan theta dash 1 plus epsilon y upon 1 plus epsilon x. So this value I am getting as, check it your calculations, 1.000313. Now the percentage change in the slope. Percentage change in slope. Which is equal to tan theta dash minus tan theta into 100. Now you can calculate this value, you are getting as 25.039 percentage. So answer will be 25.039. Okay. Mr. Alok Pratap Singh is given the correct answer, 25.039. The answer for this given question is 25.039. second figure expression repeat again. Width will increase now. When the length of the pressure vessel increase, length will increases. B dash. How to get the final width now? Initial width with plus change in width. Initial width plus change in width. B dash is equal to B plus delta B. What the delta B by B? Width is coming in which direction? X direction. Width is coming in X direction. So this will become as what now? Epsilon X. Width is coming in which direction? Epsilon X direction. This is a width. You can see the figure now. So width is in which direction? Now this is a width. So what the epsilon X? Change in width upon virginal width. So delta B by B will become as epsilon X. And what about the epsilon Y? Delta D by D. Epsilon Y. Y direction, which dimension I am getting now? Depth of the rectangle. That fight is what now? D dash is equal to D plus delta D. So if I am going to divide by D, 1 plus delta D by D. So this will become as epsilon Y. So answer is 25.039. Here also you have to divide it by B. Here also you have to divide by B. So we'll come to the next question. So the numericals are given like this. Don't see the, sir, practically this much is possible. The numericals are for the given numericals, we are doing the questions. So practical is what are possible or not. We are not going to be what as per the given numericals, we are doing the question now. Next, I'm coming to the one more question on the Mohr circle. For a point under biaxial state of stress, principal stress are 100 and 200 megapascals. 100 and 200 megapascals. Normal stress on an oblique plane inclined at an angle of theta is 80 megapascals. And what is the angle of obliquity for the oblique plane? For the oblique plane inclined at an angle of 90 plus theta. So there are two planes are given. One is inclined at an angle of theta, other one will be 90 plus theta. Complementary planes are given. On one oblique plane at an angle of theta, normal stress is given. Now it's asking what is the angle of obliquity for the complementary plane for the first oblique plane. So can you do this question now? This question can be done with either altical method or graphical method. Anyone you can do it now. Sigma 1 is 200 megapascals. One minute, there is once again a printing mistake is there. With a printing mistake, it is a 20 megapascals. This will change it. This is 20 mega. Principal stress are 120. It is not 200. There is a printing mistake. Typing mistake is there. Is not 200. You can also do it, but I done the calculation. Taking the sigma 2 is going to be 20. So sigma 1 will be I done the calculation. Sigma 2 is 20. Somebody can also try with by taking 200 also you can do it now. If the 200 is what? Now sigma 1 is 200, sigma 2 is going to be 100. Next, what is given in the question now? Normal stress at an angle of theta is 80 megapascals. If you take the 100 and 200, this 80 is not valid now. 80 is not valid. That's why it should not be 200. It should not be 220. This is a maximum value, this is a minimum value. So the normal stress remaining, all the plane will lie between 100 and 20. So it is given what now? 80 is given. If the 100 and 200 is given, mean what now? The normal stress on any plane should lie between 100 and 200. So 80 is not possible now. 80 is not possible. That's why it should be taken as 20. 80 is going to be 20. Next. Now it's asking what is the angle of obliquity. Angle of obliquity. So can you give the answer? What is the angle of obliquity? Phi is the word, angle of obliquity. It is the angle between resultant stress and normal stress on that plane. This is normal stress. Shear stress. Is the resultant stress. This angle is phi. I'm calling this sigma n dash. Okay. So that tan phi is equal to this is the angle of obliquity. Angle of obliquity, the angle between resultant stress and the normal stress. Normal stress. Tan phi equal to tau s by sigma n. Now you have to find out the tau s and sigma n. Both are not given. Both are not given. But what is given in the question now? Normal stress at an angle of theta is given. But we need the normal stress at an angle of 90 plus theta. 90 plus theta. And shear stress. What do you have to do it now? Sum of the complementary normal stress always equal to sigma x plus sigma y. So sigma n at an angle of theta plus, I'm going for the analytical method. Somebody can also use the Mohr circle. With this relation, sum of the normal stresses on two complementary planes is equal to always sigma x plus sigma y. Sigma x plus sigma y is equal to sigma 1 plus sigma 2. So this is given as 80. It will be 40 megapascals. We'll check it. Anybody has given the value now for this question? Then how to get the tau s now? We got the normal stress, we got it at an angle of 90 plus theta. So how to get the shear stress at an angle of 90 plus theta? You can use your Mohr circle equation. You can use your Mohr circle equation. By using what the Mohr circle equation? Sigma n what the circle equation? X minus xc whole square plus y minus yc whole square equal to r square. That is sigma n. What the center x coordinate? Sigma 1 plus sigma 2 by 2. Radius of the Mohr circle will be sigma 1 minus sigma 2 by 2. So now you can substitute it now. We know the normal stress. Normal stress is 40. Sigma 1 and sigma 2 are known. Then you can find out the tau s. So what the sigma n? 40. Sigma 1 and sigma 2. This is 6. I'm taking at an angle of theta. So this is 80 minus 60 whole square sigma 1 minus sigma 2 by 2. So from this one, you'll get the tau s. Can you calculate this tau s value now? Tau s value is 34.64. Then complementary shear stress are always equal. At an angle of theta, shear stress is 34.64. And at an angle of 90 plus theta minus, you are going to get it now. Minus tau s. The plus or minus are represent the directions. One is the clockwise, one is the anti-clockwise. Complementary shear stress are always equal, unlike in nature. Now you can find out now. So angle of obliquity for a plane at an angle of 90 plus theta. Tau s at an angle of 90 plus theta upon sigma n at an angle of 90 plus theta. Uh, 34.64 upon what the sigma n? Sigma n is 40. So can calculate this value. We are getting as 40.89 degrees. So this is the answer for this given question. Same thing, you can also find out the angle of obliquity at an angle of theta. If you want to get the angle of obliquity at an angle of theta, then you have to write down the tau s upon at an angle of theta upon sigma n at an angle of theta. Somebody can also use the Mohr circle, also can be used now. But instead of drawing the circle, I write in the equation, Mohr circle equation. Mohr circle equation will be sigma n at an angle of theta minus sigma 1 plus sigma 2 by 2, because x coordinate of center of Mohr circle will be sigma 1 plus sigma 2 by 2, plus y coordinate is 0, tau s at an angle of theta whole square, sigma 1 minus sigma 2 by 2 whole square. So what is the advantage of this equation? If I know the principal stresses, if I know the principal stress are given in the question, and if I know the normal stress on one plane, I can find out the shear stress. In the question is given normal stress at an angle of theta, then you can find out the shear stress at an angle of theta. Then shear stress at an angle of 90 plus theta will be minus of this one you are getting now, because complementary shear stress are unlike in nature. So we are coming to the next question. So taken a question on the strain energy. Resilience of the stepped bar shown in the figure due to its self-weight. Gamma is the weight density of the bar in Newton per meter cube. Newton per meter cube. Default resilience is the strain energy in the elastic region. Most of the time they are mentioning the strain energy. Default strain energy means a resilience only. Because we are considering the elastic region. The student who has attended the similar question, I used to do it in the general classes, but once again this question most of they are going to the mistake now. A stepped bar is given. The top one diameter is 2d, bottom one is going to be d. Now you have to find out the strain energy of this bar. Strain energy of the bar. Can anybody try this question quick? This diameter is d. So if I am assuming this is the first bar, is the second bar, its area is A. This area will be 4A. This weight will be 4W. So the reaction will be (5W). Reaction will be 5W upward. You have to, these are what a series connection. So the strain energy is given by U1 plus U2. But in the first bar, only self weight is there. But in the second bar, there are two loads are there. The weight of the bottom bar will become as a pure axial load. So in this bar, you are getting what now? Self weight as well as what now? Pure axial load. So your reaction will be so in this bar you are getting only self weight. But if you go for the second bar, so in the second bar, pure axial load is there as well as self weight is there. So the strain energy is given by U1 plus U2. U1, in this case there is no pure axial loading, only self weight is there. So due to self weight, what is the strain energy now? Due to self weight, the strain energy is going to be W square L by 6 AE. Strain energy due to self weight is what? W square L by 6 AE. This is U1. Because of its self weight. Otherwise, you have to do the integration. If a student is unable to recollect it now, what the strain energy equation under axial load? Integration between A and B, Pxx whole square dx upon 2AE. You have to do the integration. The strain energy due to axial load is given by this is a generalized equation. Generalized equation. So now you can substitute the W value. What the W value here now? Pxx is what? The gamma Ax. So if we can substitute it, you are going to get the W square L by 6 AE. Next, how to get the strain energy of the second bar? In the second bar, there are what now? One axial load is there and pure axial load is there. Self weight is there as well as the pure axial load is there now. W will be a pure axial load and self weight is a 4W. So U2 is given by, you have to go for the here we cannot use the superposition principle. Strain energy is the second order function, quadratic function of the load. So superposition principle is not valid. Here at a cross section XX, there are two axial loads there. One axial load due to W, one axial load due to self weight. Where superposition principle is not valid, then you have to go for the integration. If I draw the free body diagram for the second member, no. Second bar. What the weight of this bar? The total weight of this bar is 4W. Now what is the weight of this yellow color portion, below portion? For a length of L, the weight is 4W. For a length of X, it is what now? 4W X upon L. This is what now? For a length of L, it is 4W. For a length of L, it is therefore at this cross section there are two axial loads there. One is W, one is what now? 4W X upon L. But one is a constant, one is varying, where superposition principle is not valid. So at this arbitrary cross section, there are two axial loads there. One axial load is a constant, one axial load is varying, where superposition principle is not valid. We cannot directly add the strain energy due to pure axial load and strain energy due to self weight. So what the axial load at XX now? Hence, you have to go for the integration has to be done it now. Most of the students, they are going to add the strain energy due to pure axial load and strain energy due to self weight. Now you can substitute this value here now. Then you can do the integration. So some friends are already given the answer B. B the incorrect, my dear friends. For this question, some friends are already given the answer is B. B the answer when you are going to do the superposition. But your superposition principle is not valid. You have to go for the integration. So now U2. What the area of this bar now? 4A. E. Limits are what? 0 to L. So what the axial load at XX now? W plus 4W X upon L. Now you can do the integration this now. Now you are going to get this value will be, expand the term A plus B whole square, A square plus B square plus 2AB. Then you can do the integration. So you are going to get it. One value will be other value will be 2 by 3 W square L upon AE. Other one is W square L upon 2AE. Now this is due to pure axial load. This is due to pure axial load. This is due to self-weight. Then you are going to get one extra term. A plus B whole square is not equal to A square plus B square. A square plus B square plus 2AB. This is due to pure axial loading. That is due to W. W is the pure axial load. And this is due to self-weight. Most of them are going to add these two. Then you are going to get option B. But here extra term will be there because of it is a quadratic equation. So second order function will be there now. Strain energy is proportional to load whole square. Where superposition principle is not valid, then you are going to get an extra term. So now this value will be, you are getting 31 upon 24 now you can add the U1 and U2. You can add the U1 and U2. But in the first bar only self-weight is there. But in the second bar axial load is there as well as self-weight is there. Two axial loads are there. Axial load at x-axis is what? W plus 4W x upon L. So whenever there are two axial loads are there, one is constant, one is varying, where superposition principle is not valid. Similarly, what now? There are two bendiments, one is constant, one is varying. Superposition principle is not valid. Similarly, whenever there are two twistment, one twistment is constant, one is varying, we cannot use the superposition principle. Then you have to go for the general method integration. Then finally, U is equal to U1 plus U2. So this you are getting as but in the question W is not given. Options are given in terms of gamma. But what the W value? No, W value will be what now? What the self weight of this bar now? What the self weight? W is equal to what now? Gamma AL. Now you can substitute in place of W gamma AL. In place of W you can substitute the gamma AL. Then you are going to get the answer will be so option C is correct now. For this question, option C is correct. Option C. Option B is correct. Now most of them are going to get the option B. They are going to add the both the strain energies directly due to axial load and self weight. They are going to neglect this value now. If you neglect this value, then you are going to get the option B. Option B is incorrect now. So some friends are already got the correct answer. Mr. Naveen, Anshuman Pandey, they got it as C. So remember what now? At any arbitrary cross section, there are two axial load. One is varying, one is constant. Similarly, two bendment, one is varying, one is constant. Where superposition principle is not valid, you have to go for a general method. Integration is going to be required now. So we'll come to the next question. Rod ABC has been bent. Rod ABC has been bent into the shape shown in the figure. Deflection at C. A rod is what now? Bent it like this. So this angle is 90 degrees. A rod of diameter D, it is bent in the form of what now? L shape now. Now load is applied at C. One end is a fix. Now it's asking what is the deflection at C due to this load now. So for this type of questions, always you have to go for the Castigliano's theorem. For this type of questions, you have to go for the Castigliano's theorem. Find out the strain energy, and that strain energy should be partial differentiated with the load acting. Now you have to find out the strain energy of this now. You have to find out the strain energy of AB and strain energy of BC. In the BC member, this will become as just like a cantilever beam. So cantilever beam subjected to point load. So here you are getting one bendment and one shear force. But always strain energy due to shear force is neglected. If nothing is mentioned, always strain energy due to shear force is neglected. Therefore, you have to consider strain energy due to bendment. But with respect to AB member, this load will be a what now? Transverse shear load, eccentric transverse shear load. In AB member, you are getting three loads. One twistment, one bendiment, one shear force. Once again, shear force is neglected. So AB member, twistment is there and bendiment is there. Therefore, here you have to consider strain energy due to bendiment and twistment. Here you have to consider strain energy due to only bending moment. So for this member, this load P is a eccentric transverse shear load. Eccentric transverse shear load. For BC member, transverse shear load. So this will become as just like a cantilever beam subjected to point load. But AB member, this load will become as a eccentric transverse shear load. Whenever a eccentric load, what the principle you have to use it now? You have to use the two dummy load should be used it now. If I can introduce about now. Two dummy forces P two dummy forces. Now this P and this upward P will form a twisting couple. This P and this P, they will form a couple in which plane now? Profile plane. This P is what now? Downward. This P is upward. So these two will form a couple in a profile plane. That will become as a twisting couple. And this will become as a constant at point load. So an AB member. Now if we draw the free body diagram for AB. So this P, downward P and upward P will form a twisting couple. So what the free body diagram for the AB member now? What the eccentricity L by 2. This length is given as L by 2. So here how many loading you are going to get it now? One twisting couple, one constant point load. Due to constant point load, you are getting a shear force and bendiment. Shear force and bendiment. But shear force is neglected. Next, this is AB member, BC member. Is the first member. So add the strain energy of both the members now. So here we are getting about now. What the strain energy due to constant at point load? Shear force is neglected. W square L cube by 6 EI. And strain energy due to twisting moment. T square L by T2 GJ. But here you are getting shear force and bendiment. Then shear force is neglected. U is equal to U1 plus U2. What the U1 now? Strain energy due to twisting moment. Strain energy due to bending moment. And strain energy due to shear force. But this is neglected. Always the strain energy due to shear force is very small in comparison to strain energy due to bendiment. Default you can neglect it. Whenever a bendiment and shear force is there, you can neglect it. Now you can find out the strain energy due to twistement and bendiment. T square L by 2 GJ. Strain energy due to bending moment. W square L cube by 6 EI. If you can neglect this twisting couple, it will become the cantilever beam. Cantilever beam subjected to point load. Then the directly you can use the work done concept of W into deflection. So due to P, W square L cube by 6 EI. Now you can substitute the value. What the twistement now? PL by 2. What the W value now? P. So you can substitute it. PL by 2. 2 GJ. P square L cube by 6 EI. Next, what the strain energy in the second member now? Strain energy due to bending moment. So strain energy due to shear force is neglected. Once again, it will become as just like a cantilever beam subjected to point load. So the strain energy is going to be given by work done concept of W into deflection. What the deflection of a cantilever beam subjected to point load at the free end? WL cube by 3 EI. Half W square L cube by 6 EI. But here L is what now? L by 2. What the length of this member now? L by 2. Otherwise, if you don't know this, if you are unable to recollect it, you can go for the integration. Integration between A and B, mxx whole square dx by 2EI. If you are able to remember the standard equation, you can save your time now. So now you can add this both the strain energies. So U1 plus U2. U1 plus U2. And in place of I, we can substitute pi by 64 d to the power of 4. And j is equal to what? Pi by 32 d to the power of 4. But g is not given in the question, but it's given. Poisson's ratio is given in the question now, 0.25. Now you can simplify it now. So if we can simplify this one, we are getting as, if I can take out the P square L cube by P square L cube, if I can take out the common, this here getting 3 by 16 EI and 1 by G is equal to E by 2 into 1 plus mu. Mu is given in the question 0.25, that you can substitute. J is equal to pi by 32 d to the power of 4. I is what? Pi by 64 d to the power of 4. Now you can substitute it. Now you can simplify it now. You are getting this relation as, I'm not doing the simplification, directly I'm writing. So this is the strain energy of the bent bar by neglecting shear force. I is equal to pi by 64 d to the power of 4. J is pi by 32 d to the power of 4. And G is equal to E by 2. From this one, you are getting this value is 0.4 E. Now you can use the Castigliano's theorem. So deflection at C is equal to partial differentiation of the strain energy with respect to constant point load acting at C. Constant point load acting at C. This is the Castigliano's theorem. Then you are getting as 44 PL cube PL cube. So option B is correct now. B is the correct answer for this question now. B the correct answer. So already friends are given correctly now. Most of the friends, they are going to neglect the strain energy due to twistment. They are going to neglect it. They will consider only strain energy due to bendiment. Total strain energy should be considered. In AB member, twistment is also there. So you have to consider AB member twistment as well as bendiment. In BC member, only bendiment. Then answer will be B. Answer is B. I'll take up the one question on thermal stresses. One question on thermal stress. It's a very standard question, but I modified this question. This question is repeated so many times in the GATE and engineering services, but there the cube is restricted in the 3 directions. But here the cube is restricted only 2 directions. A cube of side A is constrained in 2 perpendicular directions. Change in volume of the cube when its temperature is raised by T degree centigrade in mm cube. It is a NEAT question, numerical answer type. Alpha is given, Young's modulus given, side is given, and change in temperature is given. If it is restricted in the 3 direction, what the thermal stress equation? Alpha TE upon 1 minus 2 mu. When restricted in the 3 direction, there is no change in volume, but restricted in only 2 directions. Third direction is free, so change in volume will be there. Now that you have to find out now. I'm assuming is restricted in the X direction. This I have taken X direction and Y direction. Z direction I'm assuming is free. You can take any 2 directions. I have taken the 2 direction constraint X and Y. X and Y I'm restricting. Z direction is free. How many faces for the cube? Now 6 faces. Left side face, right side face, top face and bottom face. But front face and back side face are free. Now this temperature is what now? Increased by so reactions are developed only in 2 directions. Reactions are going to be equal because of what? The cube expansion in all the directions are same. Dimensions of the cube in all the directions are same. A. Therefore, thermal strain in all the 3 directions are going to be equal. So the reactions in 2 directions are same. Third direction is going to be 0. It is not restricted. So Rx is equal to Ry is equal to minus R. The biaxial state of stress. You are going to get a biaxial state of stress. So in this case, what the change in volume is non-zero. If it is restricted in the three direction, you can use the change in volume concept and equate to zero. But here change in volume is non-zero. But change in dimension in x direction and y direction is zero. So how to solve this question now? Now how to find out the sigma? How to find out the sigma? Equate the strain in either x direction or y direction to zero. Equate the strain in either x or y direction to zero. So from that one you can get it now. In x and y direction, how many strains are going to be there now? So either epsilon x or epsilon y. In x direction, how many strains are there? One longitudinal strain and one lateral strain due to stress in y direction, and one thermal strain is going to be there now. So what the equation now? 1 by E sigma x minus sigma z is 0, sigma z is 0 plus thermal strain. Temperature increase, thermal strain is going to be alpha delta T. This is about the mechanical strain. This is about the mechanical strain due to reactions. This is about the strain due to change in temperature. And this should be equated to 0. Sigma x and sigma y is equal to equate to 0. Now you can simplify it now. So compressive nature. But if it's restricted in the three directions, if restricted in the three direction, you have to go for sigma z also. But there, in that case, you can also use the volumetric strain concept also. But here, when restricted in the three direction, change in dimensions are 0 and change in volume is also 0. But here only change in dimensions are 0. Change in volume is not 0. Therefore, you have to go for this method compulsory. But when restricted in the three directions, what the sigma equation now? Is a standard question. This is when restricted in the three directions. When restricted in the three directions, but is restricted in the two directions. This is a standard question. But in the question is not asking the thermal stress. It is asking what is the change in volume. Change in volume. Now you can use the volumetric strain. Now we can substitute this alpha value, T value and E value now. Alpha is given in the question. T is given. T the change in temperature. T the change in temperature. Young's model is given. Mu is given. E is equal to K. E and K are equal means Poisson's ratio is 1 by 3. E is equal to K means Poisson's ratio is 1 by 3. Now you can substitute the alpha value, T value and E value and Poisson's ratio. Then you are getting this value as 300 megapascals compress you are getting. 300 megapascals compressive. Alpha is given, T the change in temperature, Young's modulus, Poisson's ratio is 1 by 3. When Young's modulus and bulk modulus are equal, Poisson's ratio is 1 by 3. Now you can use the volumetric strain. This is a volumetric strain due to reaction, that is due to sigma x, sigma y, sigma z. But your change in volume is also there. So what the volumetric strain due to change in temperature? This is what now? Volumetric strain due to reactions. But there is also change in temperature is also there. Then at that time the volumetric strain is 3 alpha delta T. This is a strain due to reactions. Volumetric strain due to reaction. This is a volumetric strain due to change in temperature. Now you can substitute it now. Mu is known, E is known. Sigma x and sigma y are 300. Sigma z is 0. Sigma z is 0. Now you can substitute it. Minus 300 minus 300. Sigma z is 0. Alpha is 10 into 10 power minus 6. And change in temperature is, how much is given the change in temperature? 100 degrees. Now check it. Change in volume you are getting as 2000 mm cube positive, means volume will increase. Means volume will increase. N largest will be there now. But if we restricted in the 3 direction, where you can use the volumetric strain concept, but here volumetric strain concept cannot be used to determine the thermal stress. So good. So most of them have given the correct answer, but 2 of the friends are given the 1000 is given. 1000 is given. So we'll come to the next question quick. One question will take it on the theories of failure. One question will take it on the theories of failure. For the cantilever bar as shown in the figure, ratio of factor of safety as per MDET, maximum distortion energy theory, MDET, maximum distortion energy theory to maximum shear stress theory. So this bar is subjected to axial load of 10p and a constant point load of p and a twistement of t. Now which one is the critical point? Axial load is the constant. Axial load is the constant. Axial load is the constant. Twistement is also constant, but bendment is varying. Where the bendment is maximum now at the fixed end. So critical cross section will be the fixed end. And which one is the critical point? At the top fiber. Top fiber. This is going to give a hogging. Hogging means what now? Top fiber is a tensile stress. Due to axial load, tensile load, you are getting an axial stress, a tensile. But due to hogging, where you are going to get a tensile at the top. So what the resultant normal stress at the top? Axial stress plus bending stress. At the bottom, axial stress minus bending stress. So critical point is going to be top fibers of the cross section at the fixed end. So always you have to do the design with respect to critical point. So can you put the reactions now? Vertical reaction is P. So I will show the here. Critical point is this point. Now what is the reactions at the fixed end? Vertical reaction is P. But the moment due to bending moment is what? What the bending couple here now? This length is given as, once again, it is not 5 meters. You take it as 5D. It's a printing mistake, typing mistake. The length is not 5 meters. Length is 5D. Length is 5D. Length is 5D. So your bending moment will be PL, and one twisting couple will be there now. At the fixed end or at critical cross section, that is at fixed end. At fixed end. Fixed end. Shear force is P. Bending moment is minus 5PL. That is hogging. Then twisting moment is 5PD. Axial load is at critical point. That is top fiber of fixed end. Top fiber of fixed end. At the top fiber, bending stress will be there, axial stress is there, torsional shear stress is there, but direct shear stress is 0. So sigma x will be axial stress at tensile under hogging, top will be a tensile, sigma a plus sigma b max. Sigma y is 0. Tau xy, tau t max. Now you can substitute these values now. Axial load upon area 4p. What the axial load value now? 10p. Pi d square. Bending moment is what now? Bending moment is 5pl hogging. So 32. Bending moment is 5pl. M by z. M by z. Z is pi d cube by 32. But L value is given as pi d. 1 minute, this is small correction. Pi PD. Because L is given as pi d. Pi d cube. So this will be 200p upon tensile, and this is 16t by pi d cube. But the twistment value is given in the question of 5pd, so it will be 80p upon pi d square. So sigma x can be written as now you can use here one normal stress and one shear stress is there. Normal stress in one direction is 0. Then you can use your equations now of theories of failure. As per MDET, sigma t permissible will be you know sigma x and sigma y values now. Then you are getting sigma x and sigma y tau xy. So this value you are getting as sigma x how much? No, 2.5 tau xy. So this value you are getting as 3.041 tau xy. Similarly, as per MSST, sigma t permissible sigma x square plus 4 tau xy square. This is SYT upon this factor of safety I am taking as N2. So this value you are getting as 3.202. Now we need the ratio of the factor of safety as per MDET to MSST, that is N1 by N2, you get it. So divide the equation 2 by equation 1. So N1 by N2. So this ratio you are getting as 1.053. Good. 1.053. So answer for this given question will be 1.053. Some standard equation you have to remember it, so that getting the answer is not a criterion, getting the correct answer within a less time. So if you are able to remember some standard equations, you can save your time. Those you are unable to recollect it, they are going to the actual equation, sigma 1 square plus sigma 2 square minus sigma 1 sigma 2. Then in that case you have to calculate the principal stresses now. It is the time taking now. So we'll take one question on the pressure vessels now. Question number 20. It's a simple question, but some students are going to make a mistake now. We'll check it, how many are going to get the correct answer now. A thin cylindrical pressure vessel of 500 mm in diameter is used to store fluid under pressure of 5 megapascals. Minimum safe thickness of the shell. SUT is given, SYT is given, factor of safety is given, longitudinal and circumferential joint efficiencies are given. Now you have to find out the minimum safe thickness. Minimum safe thickness, cylindrical pressure vessel. So can you give the answer quick now? Is a MCQ question, 4 options are given now. We are going to get a biaxial state of stress. Biaxial state of stress. Under biaxial state of stress, theories of failure are going to be required. So in the question is asking what now? Minimum safe thickness of the shell. Then you have to go for MDET. Minimum safe thickness. So because of this word, for ductile material, which theory is going to give the economic design, safe and economic, MDET. So you have to go for MDET. If this minimum word is not given, then you can use it maximum shear stress theory. Whenever sigma 1, sigma 2, principal stresses are like in nature, directly these are the principal stresses. When the principal stresses are like in nature, under biaxial state of stress, when the principal stresses are like in nature, MSST, MPST and strength criterion will give the same results. Here, strength criterion, MPST and MSST will give same results. But they will give the They will give the oversafe design. Mean they will give the more than the required thickness. But in the question, if this minimum word is not given, then you can use this now. But since it's given as a minimum, you have to go for economic design. MDET should be used it now. So now first you find out the hoop stress. PD by 2T. Efficiency of longitudinal joint. Efficiency of longitudinal joint. Check it. You are getting this value is LJ. LJ means longitudinal joint. Efficiencies are given. So this value you are getting as longitudinal stress. This value you are getting as, sorry, this is circumferential joint. Circumferential joint. This value you are getting as 1785. So now this will become as what now? Sigma 1. Longitudinal stress will become as a major principal stress. When the efficiencies are 100%, at that time sigma 1 is the hoop stress, sigma 2 will be the longitudinal stress. But here when efficiencies are given, then in this case this will become as the sigma 2. Sigma 1. Now once you know the sigma 1 and sigma 2, then you can use your MDET. As per MDET, SYT upon N whole square. Now you got the sigma 1, sigma 2, SYT is given, factor of safety is given. So check it, you are going to get the thickness value will be 17.29, you are going to get it. Substitute these values. Then what should be the answer? Now 17.5. So answer will be, from the given option, it will be 17.5. Option D. But most of the students are going to get the 18 mm. If you use this now, you are going to get it, thickness will be greater than 17.8. Then everybody is going to go for the 18. As per maximum shear stress theory, you are going to get it 18. But as per MDET, 17.5. So whenever is given the minimum safe thickness, you have to go for the MDET. If that minimum value is not given, then you can go for MSST or MPST or strength. All are going to give the same now. We'll take up the one more question on the deflection. For the cantilever beam as shown in the figure, deflection at B. Deflection at B. A cantilever beam loaded with the two UDLs. One is the downward UDL, other one is the upward UDL. But it's asking the deflection at B. Deflection at B. If you ask the deflection at C, then you can extend, add a one UDL and you can subtract it now. But it's asking the deflection at B. Can anybody try it now? Can you give the answer quick? Deflection due to this top UDL directly known at B. Due to this UDL acting downward, deflection at B is known. But we should also consider deflection due to this upward UDL. So now what you have to do it now? What the total load of this now? What the total load of upward UDL? What the total load of upward UDL? So many ways you can do it now. But I'm selecting a method which is going to take the less time. A method which is going to take the less time. Getting the answer is not a criterion. GATE examination, time is a criterion now. You should behave like a flywheel. Then only you are able to answer the most of the questions. What the total load of this now? WL by 2. This distance is WL by 4. Now what the shear force due to this now? WL by 2. Upward will be there now. So now we can either introduce the two dummy forces concept now. Two dummy forces concept can be used it now. One dummy force is downward, one dummy force is upward now. So this WL by 2, this upward WL by 2 and this downward will give a bending couple. So what is the free body diagram for this? Now what is the equivalent diagram now? This was a similar question is given recent one of the ISRO paper. This WL by 2, this WL by 2 will form a couple in what anti-clockwise direction. This will be now you can use the superposition principle due to bending couple. First assume only this bending couple. When a cantilever beam subjected to bending couple, what the deflection now? ML square by 2EI. And when a cantilever beam subjected to point load at the free end, what the deflection now? WL cube by 3EI. And due to UDL, what the deflection now? WL to the power of 4 upon 8EI. Use the superposition principle. deflection at B due to this point load. This load is acting at what distance? L by 2. When a cantilever beam subjected to point load at the free end, deflection will be WL cube by 3 EI. But this length is L by 2. Upward deflection. This is due to this consonant point load, and due to this couple, when a cantilever beam subjected to a bending couple at the free end, deflection will be ml square by 2 EI. M value is how much is now? ml square by 2 EI. ml square by ml square. Next, due to UDL, what the deflection now? WL to the power of 4 upon 8A. But L value is how much now? L by 2. But these are downward. I taken upward deflection positive, downward deflection is going to be negative. WL by 2. So simplify, you will get the answer now. Answer is B. Good. So if we can simplify it, you are going to get it 11 upon 384. upon 384 WL to the power of 4 by EI. I am getting a positive. Positive means upward deflection. So answer will be this will be the answer. So I'll take up the one more question. It's going to be a slightly is a concept oriented question. This is the last question. I framed it 22 or like that, but due to time constraint, already I've taken 3 hours 10 minutes. So we are doing the at most 12 or 13 questions. You have done it. Question number 8. So for this question, if a student can give the answer, he is thorough with the concept. For the shaft as shown in the figure, equivalent torque at cross section C. A shaft is supporting the two gears. One diameter of the first gear is what now? At B is 150. This 5 represent the diameter. And the another gear is what now? 120 spur gears. These lines are representing what now? Horizontal lines are representing the teeth, spur gears. A shaft is supporting the. So this is what now? First let me convert into. Okay. So this bigger circle will be the diameter of this gear is what now? 150. This is what a shaft, and this will be smaller gear, that is the 120. 120. Both the gears are subjected to ETSL. One ETSL P towards the right side. P towards right side. One ETSL 6 kilonewton downward. Every ETSL equal to what now? One TSL and one twisting couple. Now can you draw the free body diagram now? for the 150 mm diameter, this 6 kilonewton will give a twisting couple in which direction? Anti-clockwise. And for the gear C, this is gear at B. This is gear at, sorry. This is gear C. So here, I'm drawing this here now. This will be gear B. This load is given as 6 kilonewtons. So this will give a twisting couple in which direction? Anti-clockwise direction. So what the free body diagram for the shaft? Free body diagram for the shaft. 16 kilonewtons. One twisting couple in anti-clockwise direction. What the twisting couple now? Load into eccentricity. What the eccentricity value now? 150. Diameter is 150. Radius will be 75. So 6,000. This is free body diagram for at B. Similarly, C. Here the load is given P. P is unknown. Now you have to find out the P. So now what is the free body diagram now for the shaft now? P. But this will give a torque in which direction now? Torque in clockwise direction. This is P into what the radius of this now? 60. So this will be P. Now to get this P now, shaft should be in equilibrium in what now? Some of the twisting couples should be 0. So by equating these two twisting couples to 0, so this is anti-clockwise, this is clockwise. For the shaft in equilibrium condition now, we are assuming that there is no frictional torque at these bearings. The frictional torque at the bearing is taken as 0. So net torque should be 0. Means torque at B plus torque at C should be 0. So one is the clockwise, one is the anti-clockwise. From this one, you can get the P value now. Clockwise, I'm taking a positive. Anti-clockwise, so from this one, P will be 7,500 newtons. Now you can draw the free body diagram. But this view is drawn from what now? Seeing from the right side. Seeing from the right side. And this force P is going on which side now? Towards left side. This P is going towards the left side. Left side means, now this is a shaft now. I'm seeing from the right side. So this will be on what now? Left side. This is on the left side. Left side means it is coming in the front direction. So this P is what now? Going on the front direction. I'm seeing from the right side. Right side. I'm standing on the right side. So this hand is what? This side is the left side. Left side means it will be about the front side. So this P is going on the front direction now. So what is the free body diagram for this now? Now if you can draw the for the shaft here now. A and D. At B, there are load of 6 kilonewton downward. So here, load of 6 kilonewtons. And a twisting couple is what? Anti-clockwise direction. Anti-clockwise direction. So it will be 450 Newton meters. This is at B. Next at C. At C, this fourth P is coming on the left front side. This is the front side. Front side means outward. This force is P. What this force P value now? 7500. And your twisting couple is going to be clockwise. So it is also 60p. So it will be equal to 7500. This is 6 kilonewtons. This is clockwise direction. 60p. So it will be 450. So now at this cross section, so this shaft is subjected to one vertical transfer shear load, one horizontal transfer shear load. So there are going to be two bendiments will be there now. One bendiment due to 6 kilonewton, one bendiment due to 7500, but one will be in vertical plane, one will be a horizontal plane. Then you have to take the resultant bendiment. This load is acting in the downward direction. So it is subjected to bending in which direction, but which plane now? Vertical plane. And another load is what now? This 7500 newtons is coming front side. Front side means what now? Is in horizontal bending. So one bendiment is in horizontal plane, one bendiment in vertical plane. So you have to take the resultant bendiment. So in the question is asking what the equivalent torque. So one twistement here now. Then you have to find out the horizontal bendiment and vertical bendiment. Then what the equivalent torque? Square root of m square plus t square. Now you can draw the free body diagram, one vertical loading diagram. This reaction is RDV. RAV. This is 6 kilonewtons. Now it is what now? Vertical loading diagram. It is just like a simply supported beam subjected to one constant at point load. So how to get the bending at C? RdV into this distance CD. What the distance between C and D? 120. So first you have to find out the RdV. So by using the what reactions, how to find out the RdV? By using the shortcut method, how to find out the RdV? This load into distance between AB. So RdV will be 6 kilonewtons into 80 upon 300. This is 1.6 kilonewtons. So what the bending moment at C? RdV into 1.6. RdV into, that is what now? CD. Similarly, find out the bending moment due to this now. Is a horizontal bending. Horizontal bending. So what the bending moment at C? Bending moment at C in vertical plane. 1600 into the distance is 120. Is a positive. Is a sagging or hogging? No. Sagging. This is going to give a sagging positive. Next. Here load is what? Outward. This load is outward. This how much is now? 7500. So your reaction should be inward, should be there now. Your reaction should be inward. RAH RDH, load is outward. So this will give a bending moment in which plane? Horizontal plane. So this bending moment in vertical plane, this bending moment in horizontal plane. So at C you are getting two bending moments. One is in vertical plane, one is a horizontal plane. Then you have to go for the resultant bending moment. Already there is a twist moment is already there now. So what the once again bending moment at C? RDH into CD. But how to find out the RDH? Once again by using the shortcut method. This 7500 into this distance. What this distance between this? 180. So RDH is equal to 7500 into 180 upon 300. So RDH will be 4500. Now what the bending moment at C once again? Now what the bending moment at C? So this 4500 into this distance is going on the back side. Back side once again is going to be a positive, but plus or minus will not make any difference because you have to go for the resultant bending moment. Now I'm removing this. $4,500 into 120. Now you can find out the equivalent torque at C. MCH whole square, MCV whole square, estimate. What the equivalent torque now? Square root of m square plus t square. But there are two bendments are there. One bendment in horizontal plane, one bendment is in vertical plane. Most of the students, they are going to add both the bendments. It cannot be added. One is in what now? One is in vertical bending, one is on a horizontal bending. So now you can simplify this value. What this MCH now? What the bendment here now? RDH into this distance, that is 1600, not 1600, 4500 into already written 120. 1600 into 120. And what the torque here now? What the torque value got it now? 450 Newton meters. You convert into mm. 450 Newton meters. Convert into Newton mm. So now you are getting this value as 728.673. Same thing, they may ask the B. So which is the critical cross section means what you have to do it now? Which is the critical cross section means you have to find out the equivalent torque at C and equivalent torque at B. Whichever is the larger, that will be the critical cross section, and with respect to that one you have to design it now. But in the question is asking only equivalent torque at C, so directly can calculate it now. This 6 kilonewtons is acting as about a vertical plane, VTSL. It is a VTSL. So it will give a bending in which plane now? Vertical plane. And this P you are getting in what now? Is a HTSL. So it will give a bending in what? A horizontal plane. This load is outward. Therefore reaction will be inward. So it will give a bending in what now? Horizontal plane, horizontal bending. So one bendment is in a horizontal plane, one bendment is in what? A vertical plane. So both cannot be added. Then you have to go for the resultant bendingment. Actually, what you have to do it now? First you have to find out the resultant bendingment. That whole square you have to do it now. Instead of this one directly can use like this now. But first of all, how to get the P? How to get the P value now? Equating the net twisting couple should be 0. Net twisting couple should be 0. Every eccentric transfer shear load equal to one transfer shear load, one twisting couple. At B is a vertical ETSL. Then you are getting a one vertical TSL plus one twisting couple. At C, one horizontal eccentric transfer shear load is there. Then you are going to get one HTSL plus one twisting couple. These are all you have studied generally in the class. I already explained it now. But generally in the beams, you are getting only VTSL. Beams are subjected to only VTSL. But shafts are subjected to both VTSL as well as HTSL. VTSL stands for vertical transfer shear load. HTSL stands for horizontal transfer shear load. VTSL is equal to VTSL plus one twisting couple. HTSL equal to HETSL equal to one HTSL plus one twisting couple. So these are the possible questions. It is not possible what now? The subject is what? Almost a very big subject. So within the 3.5 hours. So the important are discussed here. So the PDFs of this one will be uploaded in the MadeEasy Telegram app. It will be uploaded now. Somebody is asking, sir, where you will get the PDF of this now? So the questions which are not discussed in the class. So this PDF almost I prepared the 23 questions. I discussed the around 15 to 16 questions. But still there are 6 to 7 questions are important. But the time is not permitted for me to what these questions is not possible to discuss in the given this 3.5 hours time now. So always focus on the basics and the concept, and wherever required, try to use the shortcut methods. So those you are gone through my QRC where I have given the all the standard equations and the shortcut methods I have given it now. Somebody is asking directions is same. Directions are opposite direction. One twisting couple is what anti-clockwise, one twisting couple is a clockwise. Then only net twisting couple will be 0. Net twisting couple is 0. So many bending, completely mind bending question. Somebody is asking what try to extend it up to 10 p.m. It is not possible. The time is given to me only 2.5 hours, but I have taken 3.5 hours time. So thank you one and all. So my suggestion is what are the last 2 weeks. Last 2 weeks, don't go for the extra questions. Only try to revise your what na short notes, revise the short notes and appear for mock tests. Appear for at least 2 or 3 mock tests, you appear it. And maybe the Telegram app, you are getting so many questions that you do it now. And this PDF will be uploaded, the questions which are not discussed, that also you can try it. So wish you all the best. Believe yourself. Believe yourself. Self-belief is very, very important for the success now. Self-belief is one of the main ingredient for the success. Believe yourself and try to utilize this last 2 weeks properly. Definitely. So MEDIS is supporting all the students, in not only for MEDIS students as well as the non-MEDIS students, helping a lot. So try to take the help of the MEDIS and the MEDIS teachers. Definitely you are going to get benefited. So definitely you are going to get a success. So wish you all the best. Thank you one and all. So with this one, I am closing. Thank you one and all. Thank you. So meanwhile, what if any queries are there, you can ask it now. Otherwise, we'll close the session now. So thank you one and all. Thank you.